All right, welcome to today's notes. Today we're going to look at 5.2. Day 1, we're going to evaluate and graph polynomial functions. Again, if you have these guided notes, it'll save you quite a bit of time, or you can print them out on from Google Classroom to make it a little bit faster. So let's go ahead and look at these definitions. So first off, let's look at a polynomial function. So this is just kind of standard notation. You'll see this in all textbooks. So just this a to the nth is the leading coefficient. This n is the degree, and a sub o is called the constant term. So, and this is just basically its standard form. So something you'll want to be familiar with is this chart. So a degree of 0 is like a constant. So like the number -14 has a degree of 0. Linear equations are like equations that are in like that y equals mx plus b form. So x basically has an exponent of 1. Quadratic equations are where x has a degree of 2. So like this is quadratic because the degree of the equation is 2. Cubic is where the degree of the equation is 3. So this is a cubic, because the degree of the equation is 3. And a quartic is where the degree of the equation is 4. So this is a quartic equation because the degree is 4. So you want to be familiar with those. I know for sure that's on the first quiz, and it shows up on the test as well. So let's look at identifying polynomial functions. So we need to decide whether the function is a polynomial function, and if so, we'll want to write it in standard form. So first thing we're going to do is look and see why this is or isn't a function, a polynomial function. So first off, you look at each term, and we look to see what its exponents are. So a whole number, not a whole number. So this is not a function because 2.5 is not a whole number. So all the exponents have to be whole numbers in order for it to be a polynomial function, right? So now let's look at the second one. So first thing we do is we look at each of the exponents. So this guy has an exponent of 1, and this guy has an exponent of 4. So this function is a polynomial function because each of its exponents are whole numbers. It's written in standard form, so it goes from highest to least, from greatest to least. So the fourth power goes first, second power goes second, and the first power goes last. It has a degree of 4 because that's its biggest power, which is called a quartic, and the leading coefficient, which is the coefficient of the degree, the term that has the degree, is 9. All right, so let's look at evaluating by direct substitution. So I did a lot of the work for you here because this is something that you really already know how to do. You basically just take this 3 and you plug it in to x every place you see an x. So we've basically done this before in our function notation. Remember to use parentheses because if it's negative, not having the parentheses may give you the wrong answer, and then you just go ahead and simplify it. So once you get it to this step, you can just go ahead and put it in your calculator, and that would get you to this step. All right, so let's go ahead here and practice some of these questions. So first off, we want to know whether this is a function. So we look at each of the exponents. This guy is good. So we have yes. So we need to write it in polynomial form or standard form. So the exponent, 2 to the x first, plus 13, oops, forgot the negative, goes first. And then its degree equals 1. Its type is linear. And the leading coefficient is -2. All right, let's look at number 2. So first off, we look at each of the exponents. So in this case, this guy here is not a whole number because he has -2, so the answer is no. And you can write -2 is not a whole number. So let's look at number 3. So we have 2, we have pi, and we have 1. So each of the exponents have to be a real number, or sorry, each of the coefficients have to be a real number. So these guys are okay. Those are all real numbers. So we look at each of the exponents, which are also whole numbers. So the answer here is yes. We put it in order. H of x is equal to 6x squared, and then comes the negative 3x, and then pi goes at the end. So the degree is 2, the biggest exponent. Because it has a degree of 2, it's called a quadratic. And then the leading coefficient is the number in front of the term that has the degree, which is 6. All right, so now let's use direct substitution to evaluate the polynomial. So what we're going to do is we're going to take negative 2 and plug it into each of these terms. So it's going to look like f of negative 2 equals, parentheses, negative 2 to the 4th power plus 2 times negative 2 cubed plus 3 times negative 2 to the 2nd power minus 7. So we plug that into our calculator. We should get the number 5. So you might want to make sure that you can do that and get the right number. So now let's go ahead and look at number 5. Now we're just going to take the number 4 and plug it in. So it'll be g of 4 is equal to 4 to the 3rd minus 5 times 4 to the 2nd plus 6 times 4 plus 1. So go ahead and put that in your calculator. And we should get 9. All right, so now let's look at example 3. So this is synthetic substitution. I wrote the steps down over here on the right-hand side, so you can kind of follow those steps. It's really not that bad. I know it kind of looks a little bit crazy, but it's really not that bad. So the first thing you do is you look at the problem. So each of these match with the coefficients. So the next one's to the 3rd power. Now, if we look up here, we notice that the 2nd power one is missing. So whenever something's missing, you put 0 in its place. Here's the 1st power, and then here's the constant. So basically, it just goes in order. All right, so now the first thing you do once you get it written like this, you make this bar, and then the number that you're trying to find goes out front. That's the x value. So once you get this set up, the first thing you're going to do is drop the 2 down, drop the first term down. Then you multiply. So we're going to take 3 times 2 and put that number here. So that's what it says, multiply. And now we're going to add. So we add negative 5 plus 6, which makes 1. And so now we're going to multiply again. 3 times 1 is 3. Add. And now we're going to multiply again. 3 times 3 is 9. Add. Oops, should have blue. And then now we're going to multiply again. This will make 15. You add, which will make 23. So now we know that this is our answer. So f of 3 is equal to 23. So it's kind of fun. So let's try another one. Use synthetic division to evaluate polynomial function for the given value of x. So we're going to use synthetic division, which means we're going to set up our little upside down division bar. The negative 1 goes out front. So now we're going to write down each of the coefficients. So the 4th power is negative 2. The 3rd power is negative 1. The 2nd power is missing, so we're going to put a 0. 1st power and the constant. We're going to drop down the first term. We're going to multiply. We're going to add down. We're going to multiply. We're going to add down. And we're going to multiply. We're going to add down. We're going to multiply. And we're going to add down. So this is our solution. So f of negative 1 is equal to negative 10. You can also plug in your calculator to see, but whenever it says synthetic division, you need to show this work to get full points. All right, so you try this one, see if you know what you're doing, and we'll check that one tomorrow in class. All right, so come to class with that one done. Same thing with this one. Come to class with this guy done. And that way we kind of know that you know what's going on. All right, and then tomorrow we'll start with this, and you'll be ready to go. Awesome possum.